Okay, in this video I'll demonstrate how to set up a one-way ANOVA. Sometimes if you have two groups you may want to do this. This approach is generally used when you have more than two groups. Like if you have 3 or 4 or even 10 or 20 groups, although that doesn't happen very often. But the example on page 19 of the textbook, of the Welkowitz textbook, where we have these 4 dorm halls. This is a perfect example to illustrate one-way ANOVA. And as you can see, I've got my data set up in SPSS already. I have dorm represented here with numbers 1, 2, 3, or 4. And then the score, which is the student respondent friendliness score. And you can toggle back and forth between seeing the numbers or seeing the value labels for the dorm hall variable. And that toggle is right here under View. If you view and then click Value Labels, it'll toggle it back to the different option. If you're seeing the words, you can toggle to numbers or vice versa. And the way that I set up those labels is in Variable View at the toggle on the lower left. You highlight the values box here for that variable for dorm, and then click that little button, and that's where you input the information for which dorm hall equals 1 or 2 or 3 or 4. And I already did that. So everything is set up, and what I'm going to illustrate is how to do a one-way ANOVA. Go to Analyze, Compare Means, One-Way ANOVA. That's Analyze, Compare Means, One-Way ANOVA. When I click this, I get a simple dialog box. I always like to make them a little bit larger. Dorm is the independent variable, so to speak, in this pseudo study. And I'm going to put that down here under Factor. This is where you put the independent variable. Score in this example is the friendliness score, and that's a dependent variable. So that's going to go over here. And I always check the options to see what's available. And unlike with the t-test, we see that we have a whole bunch of different options. And I'm going to ask it to give me the descriptives, the homogeneity of variance test, which I'll describe. And I want to see the means plot. It's going to give me a line graph showing me the means in relation to each other. It's maybe better to do a bar chart, but means graph is okay. And I'm going to click the post hoc, and what this is going to do is it allows me to test individually across different groups. So if I wanted to do a test of Turk Hall versus Kirk Hall, or Turk Hall versus Dupree, I can get those individual comparisons using that approach. And I'll go with Bonferroni for the sole reason that the Bonferroni test is the most popular of the post hoc tests, but you can see that there are a whole bunch of different post hoc tests available. Personally, I prefer LSD, not the drug, but the least significant difference test. It's a little bit more liberal than the Bonferroni, but since the vast majority of people go with the Bonferroni, it's sort of grandfathered in here, we'll go with that. The Bonferroni test, by the way, was developed by Carlo Bonferroni, early 20th century Italian mathematician. So we're good to go. I've got everything set up. I've got my options, the descriptive, homogeneity, and means plot, and I've got my post hoc test set up to do the Bonferroni. And I click OK, and you can see I've got a whole bunch of different output. So taking a look at one thing at a time. First we have the First we have the means and standard deviations. You can see those up here for each of the different halls. Now, if I just had the numbers and not the names of the variables, we would see numbers here. That's why I like to type in the actual variable labels so that we see names instead of numbers. And we get the descriptive stats for each one of those, including the 95% confidence interval around the mean for each one of these halls. And that's just your basic confidence interval that tells you how far the true population mean could be for each hall above or below the observed sample mean that you have. So if we just consider Turk Hall at the top, the mean is 13, and the confidence interval tells us that the true population mean for everyone else in Turk Hall who wasn't in the survey could be as low as 10.58 or as high as 15.41. Of course, we don't know that for a fact because there could be some sampling bias. Maybe the friendly people are the ones who are willing to do the survey, which would, of course, throw out the entire credibility of the survey itself as a measure of friendliness. But that's a different issue. The second thing that we see here is the test of homogeneity of variances. And this is actually really important because one of the requirements of doing these types of tests, of doing a t-test or doing analysis of variance, is that the variability of one group has to be similar to the variability of the other groups. And if you have a violation of that assumption, it can throw off your end results. So we do not want any of these to be significant, and you can see that they are not. If any of these had a p-value of 0.05 or less, then we would be sort of in trouble. But we can see that there is no reason for concern because all of these have p-values greater than 0.05. And probably the one that you want to go with is just the top one. These are different approaches to analyzing the Levine's test of homogeneity of variance. And we're looking at the one for the mean. And so these variances appear to be equivalent, more or less. And when you look at the standard deviations, you can see if there was a difference, it would show up here. And there is one for Dupree Hall. Dupree is a little bit lower than the others, but apparently it's not appreciably lower. It's not low enough that it causes concern. So with that, we can move on to the F-test. Now the F-test, or analysis of variance, is shown here, and you have the standard ANOVA summary table right here. And the key thing that we're looking at, of course, is the F. You want that to be large if you want to. If your goal is to show a significant difference, then you want this number to be large. And the p-value, of course, is less than 0.05 because the F-test result is large. What that would then indicate is that we would reject the null hypothesis of no difference between these groups. The F-test result that we see here is reflective of a difference between these sample means up here in the descriptive stats. And when you look at those sample means, you can see that, well, some of them are really quite high compared to others. Like Turk Hall is almost twice as high as Dupree. That's a considerable amount of change from one hall to the next. And we're seeing that show up here in terms of the significance of this F-test. For what we're doing now, I won't explain the different components in the ANOVA summary table, but you can see the sum of squares and degrees of freedom and the mean square of the between groups and within groups. That's your signal to noise ratio right here. The mean square is the signal to noise ratio of the F-test. If you take 79.393 and divide it by 15.815, you get 5.02. So these two numbers for the mean square, the top one divided by the bottom one, these give you the F-test. Okay, one other thing here. If we move down to the well, two other things, because I asked for the means plot. How do you read one of these? How do you read a Postdoc table? So it's kind of like a correlation table, where the correlation table repeats itself. You'll notice that each one of these four halls has a name that's been set aside over here, and then the other three halls show up inside. So Turk-Hall compared to Kirk-Hall, we find that the significance value is 0.07. So that is not significant. Turk-Hall compared to Dupree-Hall has a p-value of 0.004. So that one is significant. And you might notice that Dupree also shows up over here. So Dupree gets to get compared to Turk-Hall again. That is to say, you see a mirror image over here. This 0.04 on top is the same as this one down here. That's the same comparison of Turk versus Dupree. It's just that they put them in the reverse order. So it's kind of an important thing to be able to read this table to make sure that you don't repeat yourself. With 4 halls, you don't have this many comparisons. This is 12 comparisons, but rather you would have 6. You would have 1, 2, 3. Kirk versus Dupree, 4. And Kirk versus Doty, 5. And then Dupree versus Doty. So those are the 6 non-repeating pairwise comparisons. We call it pairwise because it's one hall versus one other hall. So the overall F-test tells you whether there's a difference in there somewhere, whereas the pairwise comparisons tell you which of these specific groups are different from each other. Okay, one last thing. Going down to the means plot, you can see the means plot arrayed here, the cell means of each group, Turk, Hall, Kirk, Dupree, and Doty. If you double click that, you can change the scale. And what I'm doing is I'm just changing the scale of the y-axis so that instead of starting at 7, it starts at 1. It's going to make it look a little bit more accurate. The way that SPSS sets things up sometimes doesn't always visually portray things that accurately. This is a more accurate representation of the results. Okay, hope you find that useful. I will see you soon.